Hello, everyone. My name is Camille McHugh, and I'm the principal of the upper school at the Adelson Educational Campus in Las Vegas, Nevada. I am so glad that you have joined me today as we discuss going viral, getting started with epidemiological models. Now, what is an epidemiological model? Well, you've probably been hearing a lot about epidemiology right now in this COVID-19 world. Epidemiology is the branch of medicine which deals with the incidence, distribution, and possible control of diseases and other factors relating to health. And a model is something designed to simulate what might or what did happen in a situation. So let's talk a little bit about these models. You've probably made mental models of things in the past. So for instance, if I said, let's scatter something out, like people in your city or in the world, then scattering is an image that you create in your head. You form a mental model of that process. We could make a physical model, and we could actually take people and put them out in a field of a rectangle of specific dimensions and locate those individuals at XY coordinates randomly. We could scatter them in the field. A computer model, though, allows us to perform something like scattering and allows us to see what happens without actually putting real people out there or real objects, whatever those may be. So a computer model can let us see what happens or hypothesis test, and it can reduce challenges associated with the time to build a model or access to the pieces that we need, or perhaps even dangerous components of a model. And when we build a computer model, we use abstractions. We make coded algorithms that we can quickly and repeatedly use in order to do something. For example, scattering people in a specific space. So what are the math content and process standards we'll be talking about today? We'll be working to develop and analyze algorithms for computing with fractions, decimals, and integers. We'll use coordinate systems, as you've already previewed scattering things. We'll create and describe mental images of paths, people moving with various vectors throughout a space. We'll compare and evaluate different representations of the same data, looking at them numerically versus physically. We'll understand and measure the likelihood of an event. How likely is it that someone gets ill? How likely is it that someone infects another person? We'll use representations to model and interpret physical, social, and mathematical phenomena. And we'll select, apply, and translate among mathematical representations to solve problems. Now, what's our game plan for this presentation? First, we're just going to talk very briefly about some model attributes. What does this model look like? And then secondly, we'll talk about some specific models, an SI model, an SIS model, an SIR model, two types. And don't worry, I'll tell you what those acronyms stand for. And our overarching paradigm for this discussion is to look at building models through the lens of conducting complex learning. We're going to break down the big model that we're going to work on building into much smaller pieces, and those smaller pieces or smaller tasks can then each be amplified and then put together in order to make the complete model. Now, what are the attributes of this model that we're going to be building? And I'll show you a quick example of what it looks like so you have a sense of what we're discussing. Here's a model, and it's going to, in just a moment, involve these little aliens moving around. So you can see what the setting is. You can also see that there's a character in the setting, and there's two variables for now. So we're going to be using the programming environment called Scratch. Many of you are already familiar with Scratch. We're going to be creating an alien world with alien character sprites, and the sprites are going to wear costumes. The healthy sprites will be wearing blue, the sick sprites red, and the immune sprites green. Now the population will start with many healthies moving around throughout their world, and one sick alien, and that's patient 0. That's what we call the first person who's sick, who starts to introduce infection into the community of the population. And there will be several variables. You saw in our starter model, there's only going to be susceptible and infected as our variables, and as we build up, we'll also include recovered and removed. Now, let's start with our first model, our SI model, and that's the model that I previewed for you. SI stands for, as you might have guessed, susceptible and infected. There's really only two states of people or aliens moving around in this population. So what we're going to do is start by making just one sprite. That's our one initial character. And that sprite will be healthy. And then we'll clone or make copies of that sprite. And we'll ask the user, how many do you want to make? Do you want to make 10, 30, etc.? There's kind of a limit to how many you can make in Scratch such that the model will still run efficiently. So I would try to stick to somewhere between 10 and 30. We'll ask all of those healthy aliens to wander around. And then we'll take that initial alien, that initial sprite, and we'll change its costume to sick. That will become our patient 0, and we will make that alien wander. So let's take a look at what this looks like before we examine the code. You'll notice that when I click the green flag, susceptible and infected are set to 0, and I'm asked, how many healthies do you want? And you'll notice that that alien is now wearing the healthy costume. So let's just say 30. Type in 30, and when I hit enter, the model begins. You see all of the healthies running around. You saw one infected or sick individual, and now every time that individual touches a healthy individual, that little alien individual becomes sick. And you can notice the variable indicators. What happens is that over time, all of the population becomes sick, and I have a susceptible count of 0 and an infected count of 31, my population of 30 plus my original patient. So let's take a look at the code. Don't panic when you see the code if you're not familiar with programming or you haven't used Scratch. It's fairly simple. All of the programming commands are code tiles. We pull them out as blocks from these categories here, and then we snap them together. And all 4 of the models that we're going to build today look very similar to one another. They start with this starter block. This is our event handler, and what that means is that I start the model by doing something, in this case, clicking the green flag. The little alien sprite will show, and we will set the variable indicators to 0. This is called initializing them. And then we will create our susceptibles and create our infecteds. Now, these are little sub-blocks, and so I need to define what's happening in those sub-blocks. So when I create susceptibles, I switch the costume to alien healthy. I want them to be wearing blue. And I'm asking the user, how many healthies do you want in the population? At that point, I enter a repeat loop. And I'm going to do the same thing for the number of times that the person said that there would be a healthy alien in the community. So that input that the user provided is the answer variable. And so I will repeat answer, create a clone of the alien, and I'm going to send that clone to some sort of random position on the screen, some random XY coordinate, and point it in a random direction, 0 to 359 degrees. So I will repeat that process over and over until I've created my entire population of healthies. And then I will set the value of the susceptible variable to the answer, which was 30, initially starting with 30 susceptible individuals. Now I move down to my infecteds. When I create the infecteds, really all I'm doing is I'm switching the costume of that original sprite to red so that he's alien sick. And then I'm going to move him to some sort of random position on the screen, point him in a random direction, and then set the variable indicator count to 1 for infected. And then I'm going to have him wander. We haven't said yet what wander is, but I'm going to have all of my healthies and all of my infecteds wandering. So you've seen that I told the infected individual to wander. I don't seem to have done that yet for my healthies. So let's take a look at what happens. Wander is this. Wander is to just simply move some short distance, and you can just make it something like 1, or you can make it randomly selected, 5 to 20 steps. And then wait for a brief buffer period so that the model doesn't run so quickly that you can't see the action. In this case, I selected half a second. If the alien's on the edge of the screen, he bounces. And here's the real key to this code block. If the color blue is touching the color red, in other words, I've got a healthy alien touching a sick alien, then I'm going to switch the costume of that alien to sick. So a healthy becomes sick as a result of touching a sick. And then I need to adjust my variable indicators. Change infected by 1 and change susceptible by -1. Increase infected, decrease susceptible. So that's wander, and when do I do it? Well, if I was a clone, then I forever wander. So as you saw previously, let's run it one more time. How many healthies? In this case, I'll try 30 again. There they are. Notice the variable indicators this time, 30 and 1. There's the first transmission. Now I've got 28 and 3, 27 and 4. And you'll notice there's a point at which it starts to really pick up speed because there's more infected individuals, and then those individuals can infect the remaining healthies. And then at a certain point, as we sort of cross over that middle zone, you see then the remaining healthies drop. And it can sometimes be difficult to catch that last individual. And in this case, here it goes. Susceptible 0, infected 31. Okay, now let's take a look at our next model. This is our SIS model, suscepted, infected, susceptible. We'll make one healthy sprite, we'll clone it to make the number of healthies, etc. You see the same pattern here, but what's new? This time, I'm going to draw a hospital, and I'm going to make that little hospital a sprite, because in the previous model, there was no way to ever get healthy again. So here, I'm going to provide that mechanism to get healthy. And if you become sick, then you aim yourself, you point towards the hospital. Once you reach the hospital restores your health. So let's take a look at this model. This is our SIS model, and let's run it. Again, you'll see I've got my alien. This time I made him a little bit smaller, so there's actually less surface area to bump into, but you'll see why. Let's see that I've got my hospital here, and run it. Let's try 40, just for the heck of it. So now there's more on the screen, there's more activity going on, and you can see them a little more clearly because there's a little more space for them to move before they reach the next person. Now you can see that once an individual is infected, they point towards the hospital and start moving that direction. The only alien not doing so is patient 0. But patient 0 could, at some point, just bump into the hospital. And if that happens, then you no longer have an infected individual in the community. So right now we still have 40 susceptible, just 1 or 2 infected, but you'll notice that when this one became infected, he headed towards the hospital, got healthy. So this is a very different model. We notice that once we've introduced a way to get healthy and an intention of an individual to go and pursue that health restoration once they're sick, then we keep our community healthier. And now you'll see, in fact, all of the individuals have restored health. I'll stop. You can run that several times. What's interesting also is to add more than one hospital. What happens if you add a hospital here and here? Then there's less time that an individual has to travel to get to that hospital, which means there's fewer individuals to infect along the way. So multiple hospitals will create more opportunities for health restoration. Now let's take a look under the hood for just a moment at this SIS model's code. It's going to look very nearly identical to the SI model because remember, we're building up in complexity and amplifying our code each time as we gain greater and greater precision in building a more realistic model. But we need to make a couple changes because now I've got the hospital introduced. So let's take a look. So you'll notice that the code looks very similar to what we had previously. I still got my green flag event handler. I did add in one tile when I move the alien around, I want to be able to pick him up on the screen so I can do a little testing. So I'm going to need to add in one new tile called set drag mode to draggable. So I can just pick him up and I can set him next to another alien, let them bump into one another, see what happens as opposed to waiting for him to randomly do so. I've still got my when I start as a clone forever wander, my create susceptibles, my create infecteds. But here's where things are a little different. Let's take a look at our code for wander. Everything's the same until I get down here towards the bottom. I've added in a new if-then command. If the color red is touching the color white, if a sick alien is touching the white hospital. Okay, and notice over here I've got my two sprites, my sick alien or my alien of some sort and my white hospital. and all this code's on the alien. But if a sick alien's touching the white hospital, then switch the costume to healthy because they've now regained health and adjust the variables accordingly. Susceptible goes back up by 1 and infected goes down by 1. Okay? Now, we need to amplify this model a bit more. So let's move on to the SIR model. Susceptible, infected, recovered. So in the previous model, if you're sick and you visit the hospital, then you get healthy, but then you go back out into the world and you bump into someone who's sick and you get sick again. We want to introduce this concept of immunity. So everything is the same about the model, except when you visit the hospital and you restore your health, you also then gain immunity as a result of being infected, okay? You don't get the immunity any other way. Once you're infected, you head to the hospital and then you recover and you have immunity. Let's take a look at what this looks like. Here is our SIR model. Let's run it. I now have 3 variables: susceptible, infected, and recovered. So run it. How many healthies? Let's just say 40. Let's see what this looks like. Again, note the values of the variable indicators. I've got my hospital, I've got my 6, and then when those 6 visit the hospital, they recover and they come out healthy. I have added a new costume, which is the green costume, to indicate that the little alien is now immune. I still have my 1 infected individual, and that 1 infected individual is infecting the other aliens who are still susceptible. But you'll notice that when a sick or infected individual is bumping into someone who's got immunity, they don't get sick. So you'll notice that the trend in the population is what? Susceptible is decreasing, infected is going up and down a little bit depending on who is being infected right now, but then recovered, those with immunity, is rising. And you can predict what will happen in the long run in this population. Again, it is a closed system. No one is coming in from the outside. And no one was previously given immunity from something like a vaccination. Now, what just happened was that patient 0 went to the hospital, got healthy, is immune, and now no one is left to be infected. Okay, so now let's look under the hood of this SIR model to get a little bit better sense of what's happening here, okay? Now, in SIR, everything is the same with the exception, I'm sure you can predict at this point, of the wander. Wander's still pretty much the same, and we're still saying that when a sick alien goes to the hospital, something happens. So this code block, this if-then, is still mostly identical with one exception. Instead of the alien coming out just healthy, wearing the blue costume, they're coming out immune, wearing the green costume. And as opposed to them going back into the susceptible pile with the variables, they're now going into a recovered pile. So that's why we adjust the costume and adjust the variables that we are incrementing in this particular model in this way. So really it's a small change, but it's an important change to indicate what's happening in this particular SIR model. So for our last model, we're going to look at an SIR plus. And what that means, this is not actually an official title, they're still pretty much called SIR models, but what we're adding is the removed aspect of this model. So susceptible, infected, recovered, or removed. And this would be that when the patient is infected, they don't make it, they pass. So that individual is now not recovered, but removed from the system. So you can see that the overall impact is that the population of the system will most likely drop. Let's take a look at what the SIR plus model looks like. Everything's pretty much the same, except something down here. You can guess that it's in the wander command. And there's a little bit of an extra chunk at it. And that extra chunk is taking place, again, when the individual goes to the hospital. Now, we know in the real world that if you're going to lose an individual from the system, that may not be at the hospital. But just for simplicity, for this first starting point, again, as we're building up this complex system, we're adding on just to this one command. You can challenge your students actually to add in a person who is being lost from the system somewhere else when they become ill and they don't make it to the hospital. So you can have perhaps a time factor as a result of the use of a random variable, so that as they're wandering after a certain number of seconds or a random number of seconds, then they expire and they are not recovered in the system. So let's take a look before we get deep into this code block at what this looks like. We now have 4 variables: susceptible, infected, recovered, and removed. Let's run the model. Let's say 40 healthies again. And you'll notice patient 0 is infecting other aliens. Some of them are going to the hospital and becoming recovered. We'll watch some others because it may be the case that when some go to the hospital, as some are now, some of them will disappear. So look at this removed variable. 1 is removed. That means that 1 passed. Some more are heading to the hospital. Most are emerging healthy and recovered, but 1 passed. So over time, your population will trend towards recovered, healthy, but you will have lost a few individuals in the process. You can choose to actually add a total population variable as well, and you can see that total count go down in a system where you're including removal. All right, let's go back and look under the hood here. I'll keep the model running. So you see that if a sick alien heads to the hospital, I've included a new structure. This is an if, then, else. And let's go through it. If, and I'm going to pick a random number from 0 to 3. So that's 0, 1, 2, or 3. If it's 0, in other words, what I'm defining is just a 25% chance of something happening. So if 0 is pulled in this random number generation, in other words, 25% of the time, then we will change removed by 1 and change infected by -1. In other words, 25% of the time, this is when one of the aliens expires. And then I delete the clone. It's literally removed from the system. But the other portion of the time, the remaining 75%, then what happens? Well, that's when they recover and they gain immunity. So again, switching to the alien immune costume and recovering, increasing that by 1 and decreasing infected by 1. So this is really the same as what we had previously in the SIR model. Okay? So you can see the effect of all 4 models and the slight adjustments, the slight amplification of the code as we move through in order to create increasingly more complex models that are more and more representative of the real world system and looking at an epidemiological spread. Now, let's think about our classrooms and how we'll actually implement this. Obviously, we would need access to certain tools. We're going to need laptops. We're going to need Scratch accounts. Scratch accounts are free. You can either access Scratch online or you can engage in using a downloadable version, so you can use it offline. And you don't necessarily need a laptop or a desktop computer for every student. Students can work in partners. So pair programming is an excellent method to allow you to conserve resources and also allow students to collaborate in their programming and their development of these mathematical computer-based models. So let's also think too about how we can make this relevant to our students. Community customization is one way. So student models can be built to reflect their lived experiences, incorporating the proximity of healthcare facilities, for example, in their population. If there is no hospital, as you know, it makes it really impossible for those little aliens to recover. If you have one, they can, and if you have multiple distributed throughout the population, then it becomes that much easier to keep everyone in the community healthy. That's an interesting message, and that's one that they can model right there in their Scratch system. Next, you can look at using different instructional strategies. You can vary the task difficulty levels, for example, by reducing or amplifying the code. You can provide the entire SI model and then invite them to build onto that model, or you can leave pieces blank and help them experiment and explore to see what happens. You can also vary the instructional delivery method, just providing the instructions as PDFs. You can conduct live coaching, as I've done with you, or you can record little videos, as I've also done with you. You can vary the execution, including solo and pair programming and just completion coding by providing the starter file and having them build on. Scratch also allows for multiple language use, so you can use Spanish as well as many other languages that are included under the little globe in the corner of Scratch. And then you can evaluate your students in a number of ways. Remember, the point of this is not to have a test at the end. Is to build real world models and have them experience the joy of creating something that's very much like what real world professionals would do, real world epidemiologists who are battling COVID-19 right now. So you can have students, once they've completed their models, engage in paired talk alouds, have them talk to one another and just describe what they've done. You can have teams present. You can have them share their files, or even do a video recording over the file itself and talk about how they have worked through it, as we've done here. You can have them include some screen captures and write about it in a blog, or even include the link to their models for others to explore. So I hope you have enjoyed this presentation and thought a lot about how relevant it is to what we're seeing in the world around us today. This is an exciting opportunity for your students to work like the very people that they're reading about and seeing on television, and who are working hard to combat COVID-19, as well as many other diseases that are in the world right now. So I wish you luck. I wish your students joy in working in this practical real world capacity. Please take a look at the associated handouts for additional instructions and specifics about working with Scratch, and to see all of the code blocks included there for you to use with your students. Take care, and please feel free at any time to contact me. Drop me a line at my email, camille.mchugh@adelsoncampus.org. I look forward to hearing from you with any of your questions, and also just to know how it turned out with your students. I would love to see some screen captures and some photos of you and your students in action. Take care. Thank you so much.